what I thought was, I mean, you've got plenty of questions, you could just get on and work through it yourself, but I thought we'll go through a few more examples, and then you can do the rest. So what I was going to do is move on to the, if you want to solve for the angle or solve for the radius, but I thought, well, we haven't actually done one of these three-dimensional ones yet that come up in problem solving. So we'll do this one, and then we'll do the solve for the angle, solve for the radius, and then you've got examples of everything. Okay. So we've got the volume of this solid. The end face is the sector of a circle with a radius of 4 centimeters. We've got to find the volume of this. What would you do? What would be your processes? Yeah.
You could find the area of a circle with a radius of 4 and divide it by 8.
Why divide it by 8?
Because 45 degrees is
So it's basically that whole thing again, isn't it? It's, as Steph said, it's a fraction of an entire cylinder rather than just the fraction of an entire circle. Now, if I asked you to tell me how I would work out, let's say it was the entire cylinder, what would you do to work out the volume of that? So the volume of that is the area of the circle, pi r squared, multiply it by the length, we tend to call that h. Okay. Now, if you only want a fraction of that, well, we do what we've been doing anyway. We just multiply it by the fraction we have. So in this case, we would have the volume is 45 out of 360 times, well, all that again. Pi times 4 squared times h is 10. Right? So just with all these things, the important bit is this, the fraction of it. So Steph already kind of said, well, that simplifies already, doesn't it? So what's the 45 over 360? There are 8 of them. So it's 1/8 times pi times 16 times 10. Can we do any cancellation at that point? Goes to 1 and 2. So now we've got the volume is 2 times 10 times pi, which is 20 pi. Or, I don't know what it says in the question, doesn't say anything, so we could leave it there. Or if we were going to turn that into a decimal, it would be 2.8. What are the units? Cubics. Right. So when we're solving for this, the same sort of exam technique applies. In my opinion, we always just write down the formula that we would use. So if I look at that as a diagram, I see it's a sector. I see that they're giving me arc length, so the formula I'm going to write down is arc length equals, what is it again? Theta over 360 is the fraction of the entire circle times 2 pi r. So I'm just going to write it down. So you remember when I told you about trigonometry, I said, well, just write out all those things. You might choose not to in the future, but me, if I'm doing this exam myself, I would do that. I would write that down and fill out the numbers. That's just my approach, the way I do it. Keeps everything kind of clear on my page. My next stage is to kind of identify what goes in where. All right, so start bit. So actually, here is the arc length, so I can replace that with the 17.59. The theta is the thing that I want to know, so I can 360 is good, times 2 is good, times pi is good, times r, well, r is 40. So now the thing that I need to find is clearly visible as the thing that's right. My next step would be to do all the calculations that I can do to simplify it down. So what can I do first? Yep, so let's just write out 17.59 equals theta over 360 times 28 times pi. Yep. Subtract. Why would I subtract? Add.
Sorry,
Subtract 28 from both sides. What impact would subtracting 28 from both sides have? Or even subtract, what did you say? Subtract 17.59. What would that do?
I guess
It would give me 0 equals if I did the subtract. Why do I want 0 equals? When do we want 0 equals? When we are solving quadratics. Are we solving a quadratic? No. So we're not solving a quadratic. We don't need that. We don't need to use a null factor law here. We just treat it like an equation now. Could we simplify the 28 divided by 360 first? Don't have to, I'm just kind of practicing things. Can we do that? Pardon? Common factor of 4. So we've got 7 and 90. So at the moment, writing down, so I've got 70.59 equals theta over 90 times pi. Sorry, 7 still should be there. Times 7 pi. Right. So we've just simplified a little bit. I mean, it's not majorly, the numbers are slightly lower. What do we do now, though? Why is there not going to be any subtraction? Up? When do you subtract? You subtract only when it's the opposite of something that's being done to what you want to find. So in this case, I want to find theta, right? So the only time I would subtract is if something has been added to theta. Has anything been added to theta? What has been done to theta? We've divided by 90 and we have multiplied by 7 and pi. So there should be no adding or subtracting to get rid of stuff away from theta. Is that a little link to moving stuff around I've just discovered in there? I think that might be, that's the problem when we discuss moving. Because you just want to lift the 7. No, you look at it, theta has been divided by 90 and had 7 pi been multiplied by 7 pi. Only way to remove that is to undo those things, not pick things up and move them from side to side. You have just given me clear example of why we don't move things. So what can we do? Now, does it matter with multiplication and division which order I do them? No, because actually I've got that divided by 90, but then you multiply, that line could be the whole thing. So it doesn't actually matter in this case, which is good. So, what do we do? Well, should we focus on the divide by 90 bit first? Yeah? Well, I think she didn't answer the question that I asked because she suddenly twigged and jumped in and kind of spoke over me. Yeah? So, Ryan, what do we do then? So we can times both sides by 90. Okay, that gets rid of that one. But I do now have 90 times 17.59 is equal to, well, now theta has only been multiplied by 7 pi, because I've got rid of the divide by 90. What do we do now? Divide by 7 pi. So let's divide both sides by 7 pi. That gets rid of that one, makes it 1, and this side becomes divide by 7 pi as well. So, leading on from that, my final answer will be theta is equal to 90 times 17.59, all divided by 7 pi, which now you can chuck into your calculator. Was it? 710.5. Well, what do we think's more reasonable, being that we're looking for an angle in a circle where that's only 17.5? It's not. Why is it not going to be 710? Couple of circles around. Do you have your calculator set back to degree modes? Yeah. Maybe make sure, I know you don't technically have to, but if you put brackets either side of the division, because, well, we've got 72. That makes sense, that seems to work. Okay. Now this one's nice, it's still only an arc length, but if you had an area, you would have r squared to deal with, but I'm not going to do that example, you can get to that and figure that out. But again, we are going to find the radius this time. We've been given the angle, given the arc, so same process. Do you want to just do this one for yourself, or do you want me to go through it again? Go for it. So, here's my solution. Arc, theta over 360, 2 pi r. Place the arc with 31.42. 120 over 360. 2 pi. That simplifies to 1/3. That's the 2 pi r bit divided by 3. Times by 3 both sides. Then divide by the 2 pi. You get that. You all agree at that stage? Follow that through. And if we then work out what r is, what do you get? Yeah. 3 significant figures. So is it just exactly 15? Okay, so it's 15.0. So 3 significant figures. And it's millimeters. Seems like, oh, but we don't have to put 0. Well, you've been asked what. So just because this is part of the course, what's that called? That's the degree of accuracy that you've been asked for, right? So the degree of accuracy has been 3 significant figures. Writing 15.0 might seem a bit pointless, but it tells me that it is 15 millimeters accurate to 1/10 of a millimeter. So it really is 15 millimeters. It's not 15 and a bit millimeters, it is 15 millimeters. So it tells us something about the number, the accuracies which we've given it. Alright? Well, that could be part of it, for instance. Yeah? That's where what criterion D is about. Part of it is to understand that you have to take that into consideration. Is it important that we we know that it's 15.0 and not 15.2, for instance. Is it important that we know that in a real life scenario? Would you imagine? I mean, measuring something and getting something to the nearest tenth of a millimetre, well, it does depend when you're making components for mobile phones and things. Do you think a tenth of a millimetre makes a difference?
Yes, it is.
Yes, it really does, yeah. So, that whole thing about the space shuttle going to the moon, if they were 1 millionth of a degree off in their calculations, the shuttle would have missed the moon by 100,000 kilometres or something. So, it's interesting stuff. Okay, over to you. So you now, we've just done this question, which is page 249. So you've got some of these. Find the perimeter of the sector. We talked about that, including those two lines in. You've got problems like this, where you have compound shapes. We've got a couple of 3D ones. Now you've got finding unknown values. So we've just done a couple of examples there. But you can now also head on to those questions, problem-solving ones, and we're kind of done with this first topic in the unit. All right? Okay. All good? Let you carry on now.